Okay, let's look at page 43. Continue. Question 16. Risk and uncertainty. This question about expected values. Finance Director of GTK is preparing capital budget for the forthcoming period, and then look at the proposed investment in solar panel, calculate NPV for each expected number of sunny days and overall expected NPV of the proposal, and followed by the comment on your findings. Ignore taxation in this part of the questions. All right, 9 marks here. Proposal number 1. Requested to invest 500,000 in solar panel, which would be fitted to the roof, and based on the following number of sunny days: 100, 125, 150, and with the probabilities. So with the probabilities given means that risk or uncertainty, it got to be uncertain, or it got to be risk analysis. Risk, therefore, ask for what value? Expected NPV. So you need to calculate expected NPV in view of how many sunny days. 100, 125, 150, 0.3 probability, 0.6, and 0.1. Okay, and then each scenario is expected to persist indefinitely, and this, it means perpetuity. Maintenance costs for the solar panel are expected to be 2,000 per month for labor and also replacement parts, right, per month. 1 year multiplied by 12 equal to 24,000, right, per annum, per annum. And then energy cost 700 per day, 700 per day. All right, so what you need to do is present this information in the form of table, because it involves perpetuity. Perpetuity 1 to infinity, 1 to infinity. Okay, work out. Number 1, NPV. NPV for each sunny day. NPV for each sunny day. Hundred days, 125 days, and also 150 days. Annual cost saving. Annual maintenance cost. Okay, then what do you get? Annual net saving, okay, followed by discount factor. How many percent? Given tax 30% and then before tax is 10%, right? In this part of the question, it's basically ignore tax. So no tax, we use the cost of capital before tax, 10%, right? 10%. Annual net saving followed by present value, right? Divide 0.1, divide 0.1, divide 0.1, and minus initial outlay. That's called NPV. Okay, so presentation of the answer is very important. Yeah, very important. Initial outlay is 500,000. Outflow. So annual saving 100 day per day equal to 700. $70,000, 87,500, and also 105,000. Maintenance cost 2,000 per month, 24,000 per annum. Remain same. Annual net cash flow 46,000, 63,500, and also 81,000. Then, right? So no problem. Perpetuity, because of the cash flow will be persist indefinitely. 46,000 per annum forever, constant value. Divide by 0.6 become 460,000, 65,000, and also 810,000. Then NPV become negative 40,000, and then 135,000, and also 310,000. That will be the part 1. NPV for each expected number of sunny days. Then followed by expected net present value. To get the expected net present value, the next step will be multiply probability 0.3, 0.6, and also 0.1. Then expected NPV. Oh, so easy. Just multiply them with the expected value, then sum up, become expected NPV. How much? Is it 100,000? Is it 100,000? Check. Yeah. So 0.3 multiply 40,000 negative what? 12 negative, and then equal to what? 135.6, 81,000. Okay, so 310, yes, 31,000. Right, so sum up become 100,000. Positive or negative? Positive. So positive. Comment, huh? Right? Comment. Comment as required. Positive expected NPV of 100,000 indicates proposed investment in solar panel. Will be financially acceptable. But there will be 30% or 0.3 probability of getting a negative NPV. So that indicates risk for this particular investment. However, there are 30% probability of making negative NPV when how many days sunny days? 100 sunny days. Right, when 100 sunny days. This may indicate high risk investment. So whether to accept or reject the proposed investment is all depend on the risk attitude of the management. So investment in solar panel will be financially acceptable by looking at expected NPV. But bear in mind about 30% probability of make it negative NPV when 100 sunny days, and this may indicate high risk investment. Right, not difficult, am I right? Okay, now, and then also remember for multiple choice questions, you also allowed to use the shortcut method. So look at the days, the number of sunny days, probability 0.3, 100 days, and also 125 and 0.1, 150, and then get me the expected value of sunny day. Expected value of sunny days become how many days? Is it 120? Yep, 120 days. 100 multiply 0.3 plus 125 multiply 0.6, 150 multiply 0.1, that gives me 120 days average. Average 120 days. And using 120 days to perform the NPV, that become expected NPV. Okay, here, 120 days. Average here, 120 days average. Annual cost saving, 700 multiply 120 is basically 84,000. Minus maintenance, same, 24,000. And net saving, 60,000. And divide by 0.1 is equal to 600,000. And then minus 500,000. Right, that gives rise to 100,000 expected NPV. This method is very useful whenever you do in multiple choice questions, section A or section B. Right, use expected number of sunny day to perform the calculation. Same, okay, but the missing information in this case will be the negative NPV. So from the 120 days, you can't see there will be a negative NPV of 40,000.